It is so nice to see so many of you in this room, even virtually. Thank you so much for joining us. My name is Misty Davies. I'm Dr. Misty Davies, and I am at NASA Ames Research Center. This panel this morning was sponsored by Woodward. And so thank you very much to Woodward for helping us make this happen. I am currently a project manager for NASA. And in particular, I am the project manager for a project called System-Wide Safety. And if you saw some of those pictures, if you were here early this morning and you got to see Dr. Hui Tran talk, you saw that she put up a picture of drones, autonomous drones. And my project's job is to make sure that not only those drones, but modern day aviation, that they stay really safe. And as we start to make more and more systems in the aerospace autonomous or even highly automated, we look at the ways to assure those systems and make sure that the aviation system as we move forward is as safe or even safer than it is today. I love the work I'm doing now, and frankly, I'm the most excited about it. But most of the time when I talk about the different things that I've done at NASA, the thing that most people get excited about is that I worked on a project called TESS, which is the Transiting Exoplanet Survey Satellite. And that satellite is flying now, and its job is to look for planets around other stars by studying the light curves. And so that's the thing that most people get excited about. So I am now an aerospace engineer, and the thing that inspired me to work in aerospace was the classes themselves. I started off as a mechanical engineer, and when I went to go take my fluids classes and my heat transfer classes and even my materials classes, those were the classes I loved the most. All right, let's see. At this point, I would like to introduce our professional member, Ms. Angela Kimber from Woodward. Would you please come talk to you about yourself a little bit?
Sure. Thanks so much for having me. Good morning, everybody. So I work at Woodward, which actually is a worldwide aerospace and industrial company, but we have a plant in Zeeland, Michigan. So we're right near the lake. And what I do as a senior mechanical engineer is I work in product design, which means that I help in production of parts for gas turbine engines or for the combustion system. So things that help jet engines fly, making what's called a fuel nozzle. So I actually have an example here so that you can get an idea. So in the engine itself, you need to be able to mix fuel and air. And these little guys, which may look kind of small and not that important, I have a cut up one here. You can see there's lots of unique little details inside of how we get the fuel inside the combustion engine and how we atomize it, basically like a fancy shower head. And while this may seem like we've been doing this for a really long time, as long as gas turbine engines have been around, there's lots of very rich, complex problems in how to do it better, how to be more sustainable, and how to make our planes fly safe. So that's what I do most days when I'm at work. And I work on other things too, material research and lots of aerospace-based things. But I actually didn't start out as an aerospace engineer. I went to the University of Washington for my bachelor's degree in chemical engineering. But while I was there, I started building rockets for an extracurricular activity, and I got very involved in the aerospace research for propulsion, which is a lot of what I do now. It's just in a different form. And then I went on to University of Michigan to get my master's in aerospace engineering since I liked it so much. So I've done all kinds of work in space propulsion and solid rocket propulsion and liquid propulsion. And now I do basically jet engine propulsion and combustion work. So it's a little bit about me.
Thank you so much, Ms. Kimber. I love that kind of work, and I hope we get to talk about it a little bit more. I hope there's some more questions about it. All right, and so at this point, I would like to introduce Ms. Audrey Marmon, who is our first alumni. Would you like to introduce yourself, Audrey?
Yes, good morning. I am Audrey. I go to Kettering University. I am a computer science major with a concentration in cybersecurity. I was on team 3875, First Robotics. Um, Sorry, I'm just trying to remember everything I have to talk about. Um, So I also work at Auto Owners over in Lansing, Michigan. Kettering is unique as in I go to school for half the year and then I work in my field for half the year. So I work on their security team. It's been fun. And I think that's about it about me.
No worries. That's great. So you were saying that Kettering has this program where you both work in industry and you take classes in the same year. And it
Yes.
sounds to me like those two things for you are aligned, that you're working in industry and the same thing that you're concentrating in college.
Yes. So I
That's
spend
great.
3 months in school and then 3 months at work and then it keeps going.
That sounds like a really great way to get people out and working early and knowing that what they're studying is what they want to do. Okay, so now at this point, we would like to talk to our current FRC teammates. Sarah, are you here?
Yes, hi.
Hi, how are you doing?
I'm doing well, thank you. And how are you?
Pretty good. So Sarah, can you talk a little bit about where you go to school now?
Yeah, I go to East Kentwood High School. I'm also part of FRC Team 3875, Redstone Robotics. I'm a sophomore there, and this is my 5th year doing robotics.
All right. Okay, and then I know that we were supposed to have another First Robotics team member that we were missing right before this panel. Are you here?
Is this FTC or FRC?
What'd you say?
Is this FTC or FRC that you're talking about?
This would be our other FRC panelist.
Oh, okay.
It's supposed to be Megan M. I don't see her on here, I don't think.
Okay, that's great. We will have a little intimate panel. So at this point, I really want to invite everybody who is in the room who has any questions at all to write them down in the chat. So, just as people are talking, if you're like, wow, I'd like to know more about that, just go ahead and write it down and we'll be happy to answer them. Everybody on the panel is really, excited to talk to everybody here and we'd like to get to know you better. And so I'm going to start by asking a few questions and then, like I said, anything at all that you want to know, you just put it in that chat. All right, so I'm going to start with our, it's hard for me to keep track of everybody in my feed with Ms. Kimber again, with Ms. Angela. So Ms. Angela, can you talk a little bit about the most exciting project that you've ever worked on?
Well, I've been really fortunate to work on a lot of really cool projects from, like I had mentioned before, building a rocket and launching it in Nevada when I was an undergrad at University of Washington. So that was a really cool experience where you just work with a lot of different people and you have to learn very quickly and learning how to build and work with things with your hands and applying a lot of the theory that you learned in your class to hands-on. That experience alone for a whole year, and then actually getting to go out to the desert and launch the rocket. And there's lots of programs within colleges and universities that are doing this, whether it's on a team level or sponsored by NASA. So I encourage you to get out there and try those things. That was definitely one of my highlights. I think for my graduate work, I was doing a lot of work within the plasma propulsion and electric, basically propulsion and electric propulsion lab at University of Michigan. And so we were working and partnering with NASA on Hall thrusters. And so basically those are in-space propulsion plasma devices. And we were partnered up with a project that we're trying to put on a Mars cargo ship. So that was some of the
You
work
might have a bird in the
there.
background.
Yeah, I hear it.
Wouldn't mind making sure you're on mute. Sorry about that, Ms. Kimber.
No, not at all. We have lots of room for animals on the Zoom calls these days. So and right now, the project that I like the most that I'm working on is I'm working on high temperature materials. So in the hot section of the engine, thermal management, which is our fancy word for saying how to keep things cool in a very hot environment, it's a key problem. And it's something that we've had to work on since the beginning. And there's still lots of interesting things that we're working on while we raise the temperature in the engine. So the most important thing that we're really interested in when we're talking about fuel control is your seals. So how do you stop your fuel from flowing when it's supposed to stop? And how do you make sure that you can shut it off and turn it back on as needed while you're in flight? And so to do that, you need really specialty materials that can handle that hot environment. And that's really difficult. And we've been able to get by the last maybe 30, 40 years with the same materials, but as we're going hotter and hotter, those materials aren't really working very well anymore. So we're doing lots of development with research facilities, whether it's university or with the Air Force Research Laboratory, to try to develop new materials and to change the way that we think about how we design these things. And so that is a project that I'm lead on across Woodward. We're working with other SEAL experts to try to develop that. So I really like that because it's innovative. It's very challenging. We're basically trying to create an impossible material that doesn't exist yet. And so it's a long road, and lots of kind of mistakes and assumptions made along the way that you learn a lot about it. And I get to kind of put my hand in lots of different hats. I get to put on my chemical engineering hat, and then I also get to put on my materials hat, and then I have to think about the aerospace component of it. So it's a rich project that I really enjoy.
Thank you so much. I want to hear more about that myself. I have a ton of technical questions for you about ways you might want to solve that problem.
Absolutely.
So I'm going to switch really quickly to Audrey. So Audrey, can you talk a little bit about the most exciting project you've worked on so far?
Yes, I haven't really worked on much. I'm only a sophomore in college, so I haven't gotten any huge projects. I think the most interesting thing I've worked on is probably in one of my courses where we got to basically log onto these virtual machines where we were able to look at data and decide whether or not a homicide was a homicide, just by looking at things that were deleted, just basically forensic stuff. That was probably the most interesting and exciting. It was definitely my favorite.
And did you actually manage to figure out how to train the computers to determine that information?
Yes. Yeah. So we got to do it in a lab. So we got to work at our own pace, which helped.
That's pretty cool. All right, Ms. Sarah, are you there?
Yes.
So can you talk a little bit about why you joined your first team back 5 years ago when you started?
Yeah, so I've been interested in STEM and engineering since I was little. And so when I was in elementary school, I was on the swim team, and the swim team was also in the high school. So when I got out of swim practice, I would watch the robots driving around in the foyer. And so with that, I got interested and learned about robotics. And as soon as I got in 6th grade, I joined.
Oh, that is fun. That is great. Was it open to everybody that wanted to join? Okay. Let's see. So Ms. Kimber, can we talk a little bit, sort of in the vein of inspiration? What inspired you to want to really work in the aerospace industry? What was it?
Well, I think I've always really had a love for space. And I think some of the big questions about what's out there and what's our purpose here, but more than anything, I would say it's about trying to the humanity part of it. So when I wanted to have a job, I actually went back to school later on in my life and got my technical degree in my 30s. So because I was really driven I wanted a job that was rewarding and that helped people and was kind of involved in something bigger that everyone on the planet can relate to. And so that was kind of the pull for me, was wanting to do something that that had large impact. And then, of course, I mean, flight and things that explode and propulsion and fire as a chemical engineer, I was fascinated by how you could take, these fuel molecules and just down at the molecular level even, and they combine with air and they create a change in the chemical reaction, and you're able to get thrust out of that. So everything I could sink my teeth into about the chemistry behind it, and then also just the flight dynamics about it. It was really the classes I was taking and my mentors and the very cool things that they were working on and doing inspired me to start to go from, loving chemistry and science and math into turning it into engineering, and then focusing on the parts of engineering that really made me excited. The difficult problems and like just the mystery of what's going on in the engine there, whether it be a rocket or a plane. And how to further understand it and control it and be able to kind of break the barrier and do new things with it. So
I keep coming up with all these great questions. I hope that the people in the room who want to, so don't be afraid to put more questions in the chat, and we'll start to get to them really soon. So my next question, again, sort of following on that theme, Audrey, I'm curious, you've been a member of FIRST. Can you think about how being a member of FIRST is really helping you right now as you think about your career and the things that you're moving into?
Yes, I think FIRST has helped me in a lot of like different ways, from learning just like about robotics to learning of like the marketing aspect, how to talk to people, how to give a good presentation, and like good social skills, if that makes sense. But it also taught me that you need to have really good time management skills, because you can't wait until the last second to build a robot. I mean, you can, but it doesn't mean it's going to perform well and, ultimately win. So you kind of need to plan out everything. And that helps me in college and at work, because again, if you wait till the last second to study, it is gonna bite you in the butt. But I don't know. I think it also helped me learn to work with different people. So at Kentwood, sorry, my bunny is loud. It's very diverse. So you learn how to like work with people that I don't like necessarily have the same, like not only mindset but like background, and just like different like histories, if that makes sense.
That absolutely makes sense. And I'll be honest, both those things you mentioned, I think are still, sometimes not only challenges, but sometimes, really rich things that I struggle with today. I still, I just went from being a deputy project manager to a project manager, and I thought that would be about the same. And I was just joking that I need to level up my organizational skills now, because the things that I was doing to manage my time as deputy project manager aren't quite enough to keep me on track as project manager. And certainly one of the things I do love about the way we work is that we tend, especially, the farther you get in engineering, you tend to really, especially in the international community, right? All the people of very different backgrounds and worldviews and mindsets and experiences. Actually, I love that part of my job. Okay, Madam Sarah, you have 5 years in FIRST Robotics now. Can you describe FIRST Robotics in 3 words? If you had to sum up your 5 years of experience, what would those 3 words be?
Yeah, I definitely say teamwork, components, and skill. Teamwork in that there's no real way to make such a big project by yourself. I mean, there are, but it's always better when you can, like you were saying earlier, combine all of those different ideas from all those different people with all those different brains together to create such an awesome machine. Components in that there's so many different parts of robotics. It's not just putting together a bunch of metal parts. It's learning about electricity. It's learning about design. It's learning about marketing. Everything goes into it. I mean, there's skill for there's a place for everyone in engineering and STEM. Then lastly, skill. I definitely say it's not just skill in that robotics requires skill, but also it's all about gaining skills and learning a bunch of new things, and also drawing in skills from other activities. I'm really into art. I'm an artist, and a big thing that's helped me with design is being able to sketch out those things and thinking about it from my different perspectives that I've gained and my different hobbies, and bringing all those things together.
I love that answer, Sarah. I had a great mentor when I first started at NASA, and I was put on a project that I felt like I had no background in at all. And I thought like I had to do something completely different. And my mentor said, no, 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 no. Everything you've already learned, you're still going to be able to use. Now you just have to add to it.
Yeah.
I love that perspective that you just said. I have another quick question. I'm going to go ahead and pull one quick question from the chat. And I think it's for me. It says, what is one thing at NASA you learned that really surprised you about space? And I think, you know, I've spent most of my time in aerospace. And so my time in space was mostly on that transiting exoplanet survey satellite mission. And the thing, there were lots of things I learned actually for that. One of the things that I thought was fascinating was just that so many of the stars that you see have planets around them. It's actually a much bigger number than I would have guessed. And I am completely floored that we can basically just send up a satellite that has nothing cooler than cameras and figure out that they have planets around them just because the light dips a little tiny bit around the stars. And in fact, in some of those places, you know, cameras these days are separated into pixels. It's just that, you know, 4 or 5 pixels dim slightly, and you can actually measure as it travels across the star, you know, how long it took, for example, for that planet to travel in front of the star. I just think it's fascinating that we can do that and that somebody figured out that we can do that. I love that. Okay, the next question, I'm going to go back here really quickly. Ms. Kimber, what is the best part of your career and your experience right now?
Wow, I have a lot of answers for that because I love what I do and my job, but I think it's the really rich, complex problem solving and doing that with a very large group of people from many different diverse backgrounds and experiences. So in my just a snapshot of my day at work, I work with everybody from within Woodward, quality engineers and the operators who are welding and assembling the parts, the salespeople who are working to make sure that they're getting out where they need to on the products, to the customers who are building, you know, the larger engine itself, to the suppliers who supply products for our parts. So it's a vast networking opportunity where you really are connecting and communicating with a lot of different people to solve the same problem. Everybody has the same goal in mind, which is to create a product which is, you know, critical to operate safely and effectively. And how we do that is by using everybody's expertise. I only know a very, very small percentage of what is required to make this end product. And so it's really important that I lean on those other people to learn from them. Some people at the company I work with have been there for over 40 years. And so I love talking with them and hearing the history about the products and, you know, really the networking and the working together to solve these kind of really intensely rich problems is probably my favorite part of being an engineer.
I love that answer too. You guys are so good this morning. I'm want to know more. I want to take you all the coffee. All right. So I have a question that I'm actually going to ask 2 of you from the chat, but I'm going to start with Audrey and then get Angela's perspective, because I'm curious about this question about how your perspective on this might change. So Audrey, I'm going to ask you first. And the question is, do you need to pay attention to middle school math if you want to become an engineer? Or do you have to pay attention more to college and high school math? And so Audrey, can you answer that perspective first?
Yes. So math kind of builds on itself. So like what you learn at a small, younger age will be the same type of math that you learn in college. Not to discourage anyone, because I personally struggled in math when I was little, and it hasn't like hurt me in the college. I've learned that you need to ask for help if you need help, whether that be a professor or someone like a classmate. I've also learned that no one really says no. So I had a friend my freshman year in college come into my dorm and help me every single day because I could not understand my math. So like, again, not to discourage anyone from going to an engineering school. I feel like high school and college are a lot of like. I took pre-calc in high school. So half of my year I was doing like basic calculus. And then the second part, we focused on Calc 1, and calculus builds on itself. But also like professors tend to teach it differently. So if you aren't able to learn it your first year, you may learn it the second one. I'm in Calc 3 currently, and I didn't understand Calc 2. I did really well in the class, but I had no idea what was going on. But this year, I know what's going on. So hopefully that helps.
That's great. And Audrey, I'm curious now what your perspective is, even just a little farther out.
You're looking
Audrey,
for my,
Angela.
no worries. Yeah, there's 2 A's in the room, so I have a 2-part answer. The first is that you can work in aerospace without a technical or an engineering degree. So if it's something that you're not absolutely passionate about, as far as doing the engineering side, there are so many roles for you to fill and still be a really important key player in the aerospace industry. And that's a lot of, if you're able to make the rest of the panels and listen to some of the speakers, there are people that don't have a college degree that work and do really cool things in aerospace. So if the technical side isn't something you're extremely passionate about, there's still so much that you can do. And same thing with the robotics teams. I would say that even if you struggle with math at an early age, I actually did not do very well in math in high school. I was always a really good student and I enjoyed it, but I didn't have teachers that really, I feel taught it very well. And it took having a really good math teacher to become better at it. And I would say more so than the idea of you have to be smart or good at math. I think the skill set that makes that would make you a good, if you want to go into engineering or technical, is resilience, meaning that you're going to fail many tests, you're going to fail exams, you're going to feel like you cannot understand the material because some of the stuff that you learn is really difficult concepts, and it takes a lot of work, and you're taking all these classes at the same time, and maybe you're doing extracurriculars and you have a lot going on in your family. And the idea is to just not give up. Just keep going at it. And if you fail at something, I mean, that's something that we as engineers and scientists do all the time. And it's something, if I could have told myself, my younger self, to just pick up and keep going at it, that you'll get there. I have failed many math exams. I have failed, entire classes and had to withdraw. And this wasn't even that long ago. It was while I was in school. And I just found a way to take that and redirect it into something else and reapply myself and ask for so much help. I work with my other students in the class to be able to understand the concepts and just keep at it. So I would encourage, no matter how well you feel you do at whatever it is that you're trying to achieve that maybe you don't feel like you're doing so good at, to keep asking for help and just keep applying yourself, because it may just take you longer to understand the material. There's no reason why you can't do it. Every person can do it. If I had told if my high school self could see me now and see that I'm an aerospace engineer now, I wouldn't have believed it. There was no way that I would have ever thought that I'd be in the place where I am now. So I'm truly a fan of the growth mindset, that if you want to learn something and you're passionate about it, you'll find a way to learn it. And you just need to find people that advocate and help you get there, even if it takes you longer. It's not a race or a competition with anybody else but yourself. And so whether you love math or don't, or whether you're good at something or not, if you really want it, you just got to have that resiliency to keep applying yourself to it, and you will get there.
I would like to just echo that I agree with everything Ms. Kimber said, including the number of math classes failed, withdrawn from, and I have a PhD. I have a doctorate from Stanford. And you know what? The C's and the bad grades that I got in my undergraduate and even in high school didn't stop me from getting that PhD at Stanford, because I kept going. Right? And that honestly is the biggest thing. Research says that most people have to see the same concept 3 different ways before we actually understand it. Most of the time, it takes you to look at something. So if you don't get it the first time, no big deal. Just keep going and try to look at it a different way. Find a different teacher, find a different book, go find it on Khan Academy, whatever you got to do. Right? Just look at it a different way. Eventually you will get it. And sometimes it just takes a while to soak in, frankly. Sometimes your brain just sort of has to work on it in the background while you sleep for a couple months for you to go, oh, I get it now. Yep. But you'll get there if you keep at it. Okay. So I think we also answered sort of in the background as part of this question, if your grades are terrible, can you still be an engineer and get a good paying job? And I think what we just said was yes, as long as you keep going and get better grades the next time, right? So if you just fail everything and then walk in and say, hey, I'd like a job doing this, you might have trouble. But the truth is that if you use what you learned, even in the places where you didn't succeed the first time, to succeed the next time, and you will, by the way, then yeah, absolutely. And in fact, I think you'll find that most engineers have, if you ask them if they did everything right and got straight A's, they will laugh. They will tell you no.
100% truth right there. Yeah, I
Right.
just ace everything. And in fact, I chose chemical engineering because I was really bad at chemistry. It was the one class I really struggled in, but I loved the subject matter. And it was the first time I ever started failing classes when I was in community college, and I just wanted to keep at it. And then I started to get better, but it did take a long time for those things to kind of absorb and for me to understand. And I had to learn in a different way than a lot of the other students. I was reading books, just fun books outside of class, not textbooks, to try to understand the concepts. I was trying to think about these harder problems with a new, fresh perspective. And I had to retake class. I had to retake, tests, and you just have to learn from your mistakes and keep going. So 100% on that. Yeah.
So I think I'd like to switch themes a little bit. So Sarah, can you talk a little bit about how you balance the work that you're doing with your family and your classwork? Because I think that's going to be a theme everybody has for their whole life. So can you talk about it, how you're already doing that?
Yeah, for sure. I do a lot of different hobbies. I have a lot of different extracurriculars, including robotics. I'm also a musician. And so with that, I do a lot throughout my week. I like to keep a really busy schedule. And with that, what I usually do is I have it organized. So I have a sort of routine, not necessarily written out on paper, but when I get home from school, I like to complete my homework as soon as possible. Also during robotics, before robotics officially started, we'd usually have some time to just get our homework done. And our mentors definitely prioritize, school over extracurricular. So if you need to get some homework done, do that, and then go to practice. You need to be passing your classes to continue in robotics. And so with that, the way I balance it is just making sure I have a set routine throughout my week and following through with that. That's what makes me most comfortable, and that's the way I'm able to balance and continue my life and still enjoy it all. And also making sure that I'm not doing too much at once, because I have definitely run into those problems where you're doing all these different things you love, and eventually you can't like any of them because you don't have time to.
I think that's something we all struggle with all the way through. Um, like I said earlier, sometimes there's the time management leveling up is I'm glad you're starting early, Sarah. It sounds like you've got a good handle on it. So let me go back to the chat really quickly. Can you guys talk? And this is a question for the panel in general. So if you could just keep it real brief because we're running out of time, but I do think it's really important. I think a lot of people think that engineering is just math and science. Can you talk about the importance of reading and those other activities you mentioned, like music? How important is that to your work?
I think it's insanely important to have other things. I mean, it's those other life experiences that can really help you in your field, no matter what you're doing. In a sense that um, things like there's so much more to engineering than just a bunch of metal parts on a table. It's also coming together, sharing ideas, and coming up with new ways to really change the world. And with that, like, so much goes into that. I mean, there's also a part that doesn't even have anything to do with the mechanical side, or it does in learning about it, but you also need to read up on your subject. You need to learn how to market it, how to present it, and make it look good, make it work well, etc. And so there's so much that isn't even has nothing to do with math and science. I mean, there's a bunch of other stuff as well.
So Audrey, can you tag onto that from your perspective now and thinking about balancing it all and how the other things that you have going on in your life, including things that people don't think about engineering, contribute to your engineering?
Yeah, I definitely agree with Sarah. There's a lot of other things that play into it as well. For me personally, I don't take just like engineering courses because you have to meet a specific criteria. So you take comm classes and just like a bunch of like other stuff that I personally wouldn't have known if I like wouldn't have gone to Kettering. It's just not math and science, which kind of gives you a break for those subjects.
Yep. So I have a question in the chat. I know we've only got a few minutes and this is kind of a heavy subject, but I think it's an interesting one, especially for this group. Ms. Kimber, is there ever a time that you weren't taken seriously because of your gender?
Oh, yes, it happens. And it happens across places, and it happens even when you're prepared for it. You take seminars and you have really great mentors that teach you how to advocate for yourself. And I'll just say this, even as a professional, I still wrestle with imposter syndrome, probably weekly. And I'm more aware of it now, and I have constructive ways to really fight that. And I think that's a big part of it is not really being listened to. But the best thing you can do is find other people who will ally with you, that will speak up for you if you're not heard, or you find ways to move past it and be resilient and continue to do your job well, and earn the merit that is already there. And it's something that you'll face. And I think things like this, mentoring and meeting with other women and in the aerospace and in whatever industry that you're interested in, and finding people that help advocate for you, is just to be prepared and know that you're going to face it in any field or career that you're in, or school too. And being aware of it and learning ways that you can combat it that work for you, and how to help combat it for other women as well. Speak up for them, in meetings when they're getting talked over, or present them or hire them, all the things that you need to do to kind of support other women and girls.
I have to just absolutely echo what you just said there, Ms. Kimber, both because I think sort of the theme of a lot of these questions are leading us to is really about resiliency. And that's honestly if I had to pick one thing right? That makes you good at whatever it is you're doing. It's this ability to just sort of brush yourself off and move on, but also this giving back. The actual question was, when was a time? They wanted a specific story, and I didn't phrase the question that way. And the NASA did a great thing for me at one point where, and the break begins now, where they gave me a spot at the table. Like they deliberately put a little, we had a big discussion going, and somebody in the background actually made a name placard for me, like right in the front, right in the center. And at first I thought it was just, I don't know what I thought, but I thought, oh, that's nice. I guess they gave me a spot, right front and center. But as we were talking about the safety of the system and how we needed to manage it, at some point I made what to me seemed like an obvious comment from my safety perspective, but apparently wasn't a commonly held perspective in the room. And a gentleman on the back row stood up and said, "I agree with the woman." And I suddenly realized I was the only woman in the room, right? About 30 or 40 people. And it just was one of those things that took back, even though it was and all of a sudden I realized that maybe some of the friction was not only because I was the only safety professional in the room, but because I was the only woman in the room. And so, yeah, it's a big thing. I just want to thank so much. I have learned so much from our panelists today, and I really am so grateful that I got to be part of this. So thank you, and I hope you enjoy your break. I'm sorry I ate into it a little bit with my story.
Thanks for moderating, Misty.